Hi, my name is Ram Posham. I'm a data and AI architect at Oracle. And first of all, before I proceed, I would like to wish you a happy new year. Hope you had great 2023 and looking forward to 2024. Oracle mission is to help customers see data in different ways, discover new insights, unlock endless possibilities. And to achieve that, Oracle Modern Data Platform plays a very important role. And by the way, Oracle Modern Data Platform is part of Oracle Cloud Infrastructure. Now, the goal of this video is to help you uh, analyze IoT data. Right. I mean, basically, there are two labs that are available on oracle.com. One for creating the big data cluster, and then the next one is to analyze IoT data in real time. Imagine that you have a trucking company, and as the trucks are moving around the country, you want to track their locations, you want to track their speed, you want to alert your drivers, and so on. So this is a end-to-end demo that is built on top of this big data cluster. So for these two demos, it takes about 9 hours, but my goal is to help you do this in 2 hours, in maximum about 2 hours. Let's see how it goes. All right. But before I proceed, I want to provide a quick overview of Oracle Modern Data Platform. All right. So let me do that. So let me just complete the animation here. So if you see, the modern businesses are looking for growing the revenue, right? So they're looking for new revenue opportunities, and they want to be able to forecast accurately so that you don't need to hire more people or you don't need to stock more than what you need. And also you want to automate as much as possible to reduce operation costs. And you want to engage with your customers and your employees in a better way so that you develop a stronger relationship for continued growth. Now, at the core of this platform, what we call the modern data platform, is the market-leading Oracle database. And it is still the #1 database in the world. And now we have the data warehousing and also the ability to support mixed workloads. On top of that, we also have the data lake, which is a place where you can store the large amounts of data at the lowest cost. And all these are integrated solutions. What that means is you can access the data from the data lake through this transactional database or the data warehouse Oracle database. All right. And on the left, you see, before I go to the left, you see you can also analyze the data using AI/ML. And these AI/ML capabilities are provided not only inside the database, but it's also outside the database. So if you want to use big data services to do the AI/ML, you can do that also. The advantage of doing within the database is you don't need to move the data out of the database. Now, to do all this, you need to bring the data from different sources, right? It could be operational systems, in-house developed or custom applications that are developed in-house, but it could be also packaged application. And so you bring the data, you analyze, you process it, you analyze it, and you also can combine the data using Oracle applications data. So let's say you are using Oracle SAS, ERP, HCM, and so on. You can also integrate all the data using the data that is coming from the Oracle applications. All right. So the idea of this modern data platform is to be able to bring the data from different sources, whether it's structured or unstructured. You can bring it in real time, or it could be batch, or it could be streaming. So in the demo that we are going to do, the data is going to be streamed from the IoT devices. All right. So that's what. Now, how do we differentiate with our competition is here we can have any data, right? So that is power of any, and any data you can bring, and from any applications and from anywhere. And we do support open systems, right? So open, for example, it's you can access this data using any other open tools like Python or, and if you are already using, let's say, tools like Tableau and all, yes, we do support that. So the way we differentiate is you can bring any data from anywhere and from any application, process it, analyze it, generate insights, uh, and you can generate new data products that can be used for creating new revenue streams. All right. So that's the whole idea of Oracle Modern Data Platform. And moving to the next slide. And so before I go to the next one, so Oracle can meet anywhere. I mean, if you are already using some of the third-party solutions, that's fine. We can still integrate with those applications that you may have. All right. Now, in the center, you see this is the core platform. This is the modern data platform. Now, so the goal of this workshop or these videos is to help you run this LiveLabs. So the number one is the first one is actually the first lab helps you create the big data cluster, big data service cluster, and initialize it. That's the first part. Then after that, the second live lab is to get the data from IoT devices, live streaming. Basically, we have a Kafka client that streams the data into Kafka, and then we do the analysis. We bring basically from MySQL, we access Kafka queue and analyze the data, and then what we do is actually we visualize the data using Oracle Analytics Cloud. So imagine that the trucks are moving in the country or anywhere, and as they are sending the data, what we do is every 5 seconds we capture their location, their speed, all that, and we visualize that in real time in Oracle Analytics Cloud. So as the trucks are moving, you can see their locations in different colors. In this case, we are tracking the vehicle ID of IDs 11, 12, and 10. So these are the 3 trucks that we just wanted to track for this demo. All right. And as the trucks are moving, actually, we want to identify how close these trucks are to hazardous locations. How do we have these hazardous locations? We have that data in the historical tables. So as the trucks are nearing these locations, we identify those trucks and we send alerts to them. So that's the idea. So what are the trucks to which we need to send the alerts? And the third part of this demo is analyze the driver behavior. So as the trucks are moving, we want to see their speed. We want to analyze their speed. So we want to identify who are the drivers who are going beyond 75 miles per hour. So those are the 3 things that we do. We monitor the driver's location. We find out the drivers that are close to hazardous locations so that we can alert them. And the third one is analyze the the driver's driving behavior. So that's what we do. And this is how it looks. Here we are just visualizing the data, and these data in orange lines is basically the female drivers. All right. So that's what this one is. So what I'm going to show you is how to create big data cluster, big data service cluster. That is the first part, right? Big data cluster. And then after that, actually, we are going to create MySQL and OAC using Oracle Cloud Infrastructure. So in the Lab 0, we are going to create big data cluster, MySQL service, and also Oracle Analytics Service. These are the three things then they're going to do. And now, before you create big data cluster, you have to have access to the Oracle Cloud infrastructure. So let's say you're working for a company and there is a super user OCI administrator, and that administrator has to create, has to create you as a user, BDS admin, you're one of the users. And after that, this administrator has to create a group called BDS admins group, and that user, right, add the BDS user to this particular group. So that is the next one. So this admin user is created, the admin group is created, and this user is added to this group in this step. And after that, you need to be granted, this group has to be granted certain privileges, certain permissions, because without that, it doesn't matter. Right? You cannot do anything in the Oracle Cloud infrastructure. So in this step, what we are doing is we are going to grant the required permissions, right? So, here are the things. So first, we need to create a virtual cloud network. Before we create the big data cluster, we need to create the virtual cloud network. So I'm going to show you. This can be created using a wizard. It takes few seconds to create the virtual cloud network. And then as we are going to create big data cluster, we are going to access different services. We need to be able to access the Ambari service, and we need to access the Flink service, Hive service, and MySQL service. And to do that, we need to open certain ports. We need to not open, we need to allow the traffic to those ports. So that's what we're going to do. So we are going to create 4 rules to allow traffic on these ports. Then after that, we are just going to create a bucket in OCI, Oracle Cloud Infrastructure, because we are going to store the data in that particular object storage in this particular bucket. All right. So this is how it's going to look like. So we're going to access a cloud region. In my case, in the demo, we are going to access the Virginia region. And so I'm going to create this virtual cloud network. And within that, we are going to create a big data service. All right. After we create the network, then we are going to create MySQL service and also the analytics cloud. Now, here I'm saying that you can create all these services concurrently. This big data service takes about 25 minutes. MySQL takes about 5 minutes or so, and analytics cloud takes about 15-20 minutes. So instead of doing it serially, you can do it in concurrently to save your time. All right. And to create the big data cluster, we are going to select the compartment. And you will see in my video, cluster name, we are going to enter the cluster name, admin password, and so on. And for creating the MySQL, we are going to select a development or testing option. I will show you all that. And we are going to select the compartment name. We are going to enter the instance name and so on, right? And same thing for Oracle Analytics Cloud. You're going to create the Analytics Cloud service instance name and select the compartment and whether it's VYOL and so on. So that's what you're going to do. So it takes a few minutes, but I'm going to show you how to do that. All right. And after that, what we're going to do is we're going to initialize the big data service. So to access the big data services, right, the utility node and the management node, you need to create public IPs. So I will show you how to create the public IP for accessing the utility node, and another public IP for accessing the management node. All right, we are going to download New York City bike data, and we are going to run a query to see. We are going to run it using Hive, just to show you how big data cluster service could be used for analyzing data using Hive. Then after that, we are going to log into Ambari, and we are going to by default, we don't deploy this Kafka and Flink services. So we are going to just deploy them within a few seconds. They will be deployed. And after that, we are going to download MySQL connector, basically Java jar libraries, because we are going to access Flink using from MySQL. So that's why we need those libraries. And we are also going to access a Spark. Actually, Spark is going to access MySQL. So those drivers are going to be required. All right. And then we are going to configure MySQL database. Basically, we are going to create a database called LiveLab DB. And then we are also going to configure Oracle Analytics Cloud, because Analytics Cloud has to access the MySQL. So there's something called private access channel that needs to be created. So I'll show you that. Then after that, we are going to run this the IoT demo. So we are going to monitor the truck locations. Then we are going to monitor how close are the drivers to the hazardous locations. So we have a spreadsheet that provides you all these commands. Now, the advantage of this spreadsheet is based on your big data service name, the IP addresses, and so on, it creates all the required commands for you. You don't need to really copy the commands, change them, right? So that's the advantage of that. That's how you can really speed up this demo. All right. So that's what I'm going to do. So hope you will enjoy this demo. All right. Thank you. Hi, welcome back. So let's do the labs. So first, let's create the BDS cluster, then MySQL database, and Oracle Analytics Cloud. But to do anything, we need to have a user, right? We need to be able to log into OCI and create these resources. So to create the BDS cluster, what we need to do is, first, we need to create a user, BDS admin. So that's what you see here. So create a compartment. So the first thing is the compartment is a technique, is a way of isolating or managing the OCI resources. So in my case, I already have a compartment called R portion. So I'm not going to do that. And my OCI administrator has already created me as a BDS admin. But in your case, you have to ask your OCI administrator to create a user or admin, big data service admin called BDS admin or EQ, whatever name you like. Then ask that same admin to create a group, and to that group, this user has to be added. So BDS admin is going to be a member of this group. And after that, this group has to be given certain privileges. Otherwise, nobody can log into the OCI. Nobody in this group can log into the OCI and do any work. So it's a zero trust model. All right. So those are the things those are the steps that we highlight here. And I also have the steps in my spreadsheet, which I'm going to be sharing with you all. Right. In the notes section, you will see a link for this. So the privileges that got to be granted are the following. So here you see, so here, so once you create the group has to be given these permissions. Allow this group so-and-so manage the virtual network. Allow the group to manage, the resources, BDS instance in compartment R portion. So, by the way, these commands are generated based on what dynamically generated based on what you input. So if you say if you add BDS admin here, BDS compartment, these commands will change automatically. See this one, this is what's going to change. So I mean, I'm using the Excel technique to concatenate strings. So that's all it is. So that's what, so I'm not going to create this group and all that. My admin has already created that. So just make sure that your admin does this for you. Then after that, we need to create a virtual cloud network. So let's do that. So let's go to cloud, OCI. So here, go here, networking. So I'm going to create it for this demo. So create VCN using the wizard and use this wizard, and you just call it, maybe we'll just call it VDS VCN, all right? And this is the setup block, and all the rest we can just use the defaults, all right? There's host name for the VCN, and this is for the public subnet, and this is for the private subnet. And you say next, and you can see, so the domain name is going to be this. For the VCN, for the public subnet name is going to be this, and the private subnet is going to be this. So you can just review that and say just create, all right? So it takes a few seconds to create all that. Okay. Now the next thing is we need to add these rules, because we are going to, when we create the BDS cluster, and if you want to talk to the Ambari, the management tool, these we should be able to access through these ports. So that's what we have to do. And we are going to create the BDS cluster on this public subnet. So click on this. There is a default security list. By default, it allows the traffic from SSH port number 22 and so on. So what we need to do, we need to add these rules. So we say from anywhere. I mean, we can control this also. And the port number is 7183. All right, 7183. This is for body traffic. Right, add this. So let me remember. And add one more from anywhere. We want to be able to access 8888. And this is for Flink traffic. All right. One more. That would be for Hive 8888 for Hive traffic. And the last one is for the MySQL. Because we are going to be creating MySQL in the same subnet. So that is going to be, actually port number is 3306. And that one is going to be MySQL. Okay, so if you want to see that, this is what they are. Okay, just make sure you have added these rules. Now, the next thing that we are going to do is we are going to actually create the BDS cluster. All right. So wherever you see these yellow fields, they have to be updated. All right. That is based on your environment, you need to update. So I'm going to use the cluster name as RP BDS cluster 1. You can give it whatever name you want. This is the password. And this is actually, we created the, well, just to make it, instead of RP, we can make it as, take out this RP. We can take out this also, just make it simple. BDS cluster. So I'm going to be using these names. And I have my public key in this temp directory. This is a private key. All right. This is the VCN. VCN that we created was this one, right? It's the BDS VCN. So I'm going to update this. So that's the BDS VCN. So this is actually generated automatically. And the subnet public subnet DNS domain name. So what is that? Here it is, actually. So let's go here. Public subnet, this is the domain name. You see that here, show. So this is a subnet name, DNS domain name. So you copy that here. Okay, we got that. So see that, okay. Then we want to have the subnet OSID. The subnet OSID is here. So if you see that here, that is the OSID, can copy this, and this is the, no, I'm sorry. This one is, this is the public subnet domain name. This is the public subnet OSID, public subnet OSID. So let's be careful. Public subnet, and this is the OSID. See that one? So copy that. And actually, you just see this, right? OSID subnet, it says, so it has to be subnet. So paste that. So that is this one. So see that? MLA, ending with MLA, that's what this one is. Then we are going to create a storage bucket called training in the object storage. So go here, storage, buckets. It's already there, but just for the demo's sake, let's create, repeat that. So this is where we'll be uploading some files. So that's why. So create a bucket in this compartment, by the way. So my name, that's going to be training. Or, okay, so you can have any other name. And this is the compartment name OSID. So my compartment is R portion. So that's the OSID for that. Actually, it is, you can find the compartment also, actually. But anyway, so that's cloud engineering. And if you go here, you can just show this is my compartment. See, it's ending with K4Q. K4Q, see this? So that's what it is. Then that's pretty much it. Now we can go and create the videos cluster. So go analytics and AI, big data service, and so create. So what is the, so the cluster name is BDS, right? So you enter the cluster name as BDS cluster, and the password is this one. Just copy and paste it here. Just a bit faster. And we are not creating highly available one. We are just creating with one master node or management node and utility node. So that's what you do. And this is virtual cloud network. We are not using bare metal. We are going to be using VMs. And what you do is just use 150 gigabytes. That's plenty for the master node and the utility nodes. And then this for the worker nodes, same thing. We're going to be using virtual machines and just to take the defaults. And internally, it creates a network with this CIDR block. We don't have to touch that. And it just picks the latest VCN. So it's the BDS VCN. And we're going to pick public subnet. All right. And internally, it's going to deploy the service gateway to write to the object storage and so on. So you can just leave it that way. And now we're just looking for the public key. Right? This is for the secure login to those server VMs. So we are going to select the file. Actually, I have it in my temp directory. So that's what, this is the public key. That's what I'm going to choose. And that is pretty much it, actually. So create the cluster. So this is going to take about 25 minutes, as I said. I'm going to pause the video, but what we will do is we will kick off creation of the MySQL databases, okay? So we'll come back here a little later. We're going to copy the IP addresses and all that. So MySQL database is very simple, actually. Where is that? I'm not strictly following this, but I'll come back to here. Actually, it is in this one. See this one? This is the MySQL database admin user. And so let me show you. So go to our databases, go to MySQL databases, create this one. So here, this is a compartment name, and MySQL database is, let's use this name. Right? So I'm going to be using this name. You can, and description could be the same thing. Actually, I want to select, follow this one. Select development or testing. All right, so this is the one I'm going to be using. This is not a production database, so then we are not using HeatView. The username is admin, and the password is, again, copy from here. From the password, and we are going to be using this BDS VCN. Within that, we are going to be using public subnet. All right, we are going to be creating the resources in the same network as the big data service. That way, we don't have to create traffic rules between private subnet and the public subnet, just to make it simple. So that's, and this is the shape. It picks by default. This is the data capacity. This is more than enough for the lab. And we don't have to enable backups, but because this is just a demo. Go to the advanced options. See this one, all the steps are given here, and give this as the host name. So connections, go to the host name here, enter that, and just keep the remaining everything same. Don't have to change anything else. So just say create, and it's going to take a few minutes. It's going to create this one. Now we will go to Analytics Cloud. That's another service that we need to create. So go to Analytics. Analytics Cloud, here it is. This was created in the past, but I'm going to create it with the same name. I'm just repeating the lab for you. So we can do the same thing here. In the same compartment, just one CPU is enough. Non-production, license included. Just if you want to, we can use BYOL because this is just a lab environment. Enterprise edition, yes. And that's all. Actually, here we are going to access it to the public network. So you can just leave the rest as default. So just say create. All right. So all these things, there is already a compartment instance. Is on the instance with the name in the compartment, which is a different name. Actually, that was deleted. So I think it's still excellent is somewhere. So we need to change that. Okay, so let's change it. So let's call it OAC. Just picking a name. MySQL, and so here is a thing. Okay, create OAC instance. I documented here. I did not specify the name. So we need to here we can call it BDS MAC. Again, we can just, this is not really used anywhere, but for the sake of it, let's use this name. All right, so create here. Okay, on production, UIOL, and anything else. Okay, so here we just need to specify the name, and there is no need to specify subnet and all that network, because it is a service. It's created in the Oracle Cloud Network, so it's nothing to do with your specific network. All right. So just say create. Anything else I'm missing here? OAC. Okay. So let's create that. So this is going to take another 15-20 minutes. Let's see, the BDS cluster is also getting created. So it's creating. Similarly, MySQL database, is it getting created? Yes, that is getting created, and also the same thing with OAC. So as I said in my presentation, you can create these services in parallel, all right? So let's go back to the PowerPoint while that's going on. So we did this, we assigned, we added these rules. So we concurrently kicked off the creation of these services, all right? And we use the settings. By the way, I'm going to share the spreadsheet. So I'm going to save all this that we updated. So what I would do is I will pause my video. Maybe I'll come back after 10 minutes or so once that's created, and we will resume from there, all right? All right, welcome back. I just, so if you see this BDS cluster got created, it took about 26, 27 minutes or so. If you want to know how long it took, you go to the work request. It started at 21:33, finished at, this is UTC time, by the way, 22. Oh, so that's about 27 minutes or so. Okay. Similarly, if you look at the Analytics Cloud, that got created in about 10 minutes. Then similarly, if you want to look at MySQL, that takes only about 9 minutes maybe. So this is the MySQL database. And if you want to look at how long it took, so you see 21:36, 21, it's about 9 minutes. All right. So now we are done. So let me go back to the point. So we created this. We created the network. We created the BDS cluster, MySQL database, and OAC. These are some of the inputs for those services. Now we are going to initialize the BDS environments with using the commands in the Hadoop lab tab. So if you look at the spreadsheet, this is the tab that we are referring to. So we already updated this, right? BDS cluster, all that. So now we need to go back to get the IP addresses of all the BDS clusters. So that one is, so click on this. See, these are the names. So you copy this to here, Control C, come here, click on this, and do a right click, and then you just paste it. Now you see all these names are basically same as what is there here. Then after that, what you do is sort the names, sort these lines based on the name column. So all the way from here. Then you say data sort and the name column. The idea is actually we want these names to be managed master node, utility node, worker node, and so on in that particular order we want. Because the commands that are created are based on this actual names, in this particular order. All right. So you see the display name for the utility node. The utility node is this one, right? So is VDS utility node. So this is generated. If you see this one, this is generated. And this is the private IP address. So utility node private address is this one, 10.0.0.2.1.0. It's basically copied from there to here, E35. So now what we need to do is we need to assign a public IP to this utility node and the master node so that we can access it from the outside world. So if we go to the PowerPoint, so you can see here, right? So this one, actually, if you see here, it's like master node and the utility node need to have the public IP. So the way to do that is you export the display name, private IP, and the subnets host it and run this command. So that's all you need to do. Copy this, all right, and go to this and you specify your Cloud Shell. Go to the Cloud Shell and just run these commands in the Cloud Shell. So it's going to assign the public IP. So just paste it here. See, so this is the public IP for the utility node. This is for the utility node. So just copy and paste it here. Paste that. So that is 109, right? Same thing you do for the master nodes. Copy this. And then here. Now the public IP is this, ending 62. All right. So now we can access Ambari through this URL actually. See this IP address, it came from here, this one, right? The utility node. So that one, so if you want to see whether it works, copy this, go to okay. So here you just paste that. Okay, advanced, proceed. So that is admin. And the password is, this is the password. All right. So you see all these services available, all right? So you can do the same thing with Hue also. So open another window and so here, first time you're accessing, it's going to create a user. So you can create a user account called with the name admin. So do that, and the password is same. Let's put the password here. So same thing, the Hue server and the Ambari, they all run on the utility node. So we will come back to this a little later. Now, what we need to do is we need to log into the master node to create these users, right? So what you do is you open a bash window. So it is, so coming here, bash window, so copy this, paste it here, say yes. Then you create these users, right? this DCLI is a distribution command line interface. So when you do this, it creates this group across all the nodes in the cluster, and it creates this user called training, and so on and so on. So you just copy this, paste here. See this one, this is the master node, right? So this is the Hadoop directory. And then what you do is the same window, you download, what you do is this is a New York City bike data. So what you do is just copy this and paste it here, the same window. And then it basically downloads those files, and then run these commands. Basically what it does is downloads all the bike ride data files and then copies them to the Hadoop file system. So that's what it's doing. Actually, this script, that's what it does. So paste this here. All right. So it's copying all the data. And now it's copying to the. So this script actually does all that. Downloads the file and then it copies to this particular directories. So that's what you're going to see. The final command would be just catting of this file, city bikes, just the first 5 lines. All right. So let's wait for a few seconds. Let me pause. So it's uploading the file and creating the Hive tables. You can see. So it's another few seconds. So that is done. So that's what you see, right? It's just catting this CSV file. Okay. The next thing that we want to do is you want to go back to this Hive user interface and see this here, admin, and administer users. And we want to add a user called training. So the password is actually here. And then say add user. Now log out from here and log in as training. Copy the password. Okay, we'll just walk through this one. So now we can run this actually, this SQL. All right. Now, one thing you notice is when a copy is placed into this window, it puts this double quotes. So take out that. But anyway, so that's what it is. Now we can run this. So it's basically running against the Hadoop file system, right? Hive is running against that. So it's going to take 3 minutes or so, first time. Later, it takes less than a minute. So while that is going on, let's see what we can do, all right? So go back to the here. Now, what we can do is we can, if you want to copy the files to the object storage, this is something that we can do. So, so what you do is go back to your here in this window in the Cloud Shell. So you can download that same thing, right? So get that file and run file. Okay, so I need to copy this, paste it. So now we have to edit this file. env.sh. So Here you can see what we are doing. We just need to copy this the compartment ID and all that. This is actually, see this one, this is created automatically for you. And the bucket name is training, all that. So you simply just copy this whole thing, okay, and put it into, oops, so go back to the beginning, delete all the lines, just paste that. So this is from this particular one. So you just copy and paste it here so that it has the right URLs. Then what you do is download this script. Now this download all object store, this is going to be using this environment file. That's the idea. So the next is copy this, paste. Okay, then it give the permissions to that file, execute permissions. Then you run this script. What it's going to do is it's going to download the files and then upload it to the object storage. So if you want, just go to storage, buckets, and there's a training. Right now, see, this is just getting created. There should be one more. So all these files are uploaded actually. Training. Now you see the weather folder also. So that's what it did. The script has completed this already. All right. So that's what it does. So this thing is done. Let's see what happened to the hue thing. This is still running. All right. So we completed the hue Hadoop thing. Let's go to the actual Kafka lab. So let's go to the PowerPoint. Finish this. We are almost at the end of the testing of this New York bike ride data analysis. So we'll come back to that. So now let's go back to this one. So we'll follow the steps in this one. All right. So what we'll do is we'll log into, see this one, this is a utility node. So this command will log into utility node, and we need to download the drivers for MySQL, drivers for MySQL connector for Kafka and also Flink, right? That's what it is. So these files are a Flink connector and the Kafka clients. So these are going to be used by the MySQL. So that's what we need to do. So let's copy. Let's open another. Actually, so this is another shell. So let's get it here. Yes. So this is going to be logging into the utility node. All right. So see this one, this is the utility node. Now, what we are going to do is we are going to basically run this script, and all the commands are automatically generated for you. For example, this IP address and all that you can see, just to make your life a little easy. So log in as sudo as root, and then sudo to root, and then go to the temporary directory and download this file and all that. So I'll just copy this. By the way, the DCLI is going to be copying this jar files to all the nodes in the cluster. So that's what it is. Copy this. All right. So just paste it here. And then do the same thing for the other. This is a MySQL connector. All right. Okay. Then you do the same thing for So we copied them to the Flink. We copied the MySQL connector to the Flink, and now we are copying to the Spark. Here. And finally, this is for the, we are copying to the, we are logging as Hadoop HDFS and copying these connectors to this Flink directory, all right, Hadoop file system. All right, so let's do that. Let's see. Paste. Okay. Something is so let's, oops. The mistake was sudo su. Then from here, we need to log into HDFS. So now we are in HDFS. Now this should work. All these commands were executed as root. Now these things are executed as let's one more time. Let's try this. Okay. And then sudo minus sudo minus sudo minus. Okay, then not sure why this. So like libs, that particular directory is not there. Okay, sure if this is. So let me just pause for a second and then come back. Okay, I realized a mistake. See, I skipped one step here. See this, I need to log into the Ambari, then I need to deploy Kafka and Flink service. So that was a mistake. So let me do that. So you see the services here. I don't see the Kafka and Flink. Okay, so that's what I need to do. So here you can say add service. So Kafka and Flink. Sorry about that. So let me go here next. Next. And there are some warnings which you can ignore and deploy. So this is going to take a few seconds, few minutes actually. Okay, completed. Now what you see is these things, right? It says they need to be restarted. So you have to do one by one actually. So you go here. In fact, you can do all of them also at the same time. So you say restart all affected. So it's going to take a few seconds. And after that, that alert will go away. So let's 2 more seconds. So again, let me pause for a few seconds. Let me restart all the services, okay? All right. So I was able to restart all the affected services. You see everything is clean now. There are no alerts here. So that's the way it should be. So yeah, you have to make sure that we deploy Kafka and Flink services. After that, you have to restart all the affected services. Actually, it should be services. All right. So then we need to run this one. So let's go and I already have that window. I already logged in to the utility node. So I just need to run these commands again. I don't think there's any harm in rerunning them. So just downloads and okay. So I will say all. All right. So it unzipped. Then I think we need to run this. So let's run this. All right. So that's copied. Then we need to copy this to same way. So that is done. Then we are going to copy. We are going to run these commands. Okay, then finally this one. We are going to log in as to htps and run these commands. Okay. So let's run that. Now it should work. File exists. It says so I guess it's should be okay. So they're already there. Okay. So if it is already there, I think we should be fine. Okay. All right. Previously it was not there. So that means when we install the Flink service, these libraries are already there. So I guess these are redundant command requirements, but you know that previously it was saying that that directory was not there. So now it's good. So now we'll go to MySQL database and MySQL database, we created this already. Actually, we already created this name. And by the way, this is the, after the instance is created, click the connector tab and copy the FT fully qualified name, right? So if you go here, MySQL database, and here connections, and if you see this one, right, this is the actually fully qualified name, RP MySQL DB host, all that. So it is ending with 5040, right? So that's what you see here. That's what you see here. This is generated actually. So the way Oracle generates, I generated that. See this one? And then we are already logged into this utility node, log to the utility node as root user and connect to the MySQL database. So let's log into the utility node. So we are already there. In fact, so you see, we are already logged in with utility node. Then we just need to do root and then you run these commands. Okay. So let's run that. And the password is this. So we are in MySQL prompt. Then we are going to be creating this LiveLab. So you can give any name here. This is you're supposed to enter that. So I'm just using the name that is in the lab. So I said drop the database if it's already there. So we need to run that. And then we need to run the next command, create this database. Okay. After that, we are going to create a user. So this is the username. You can enter any other name if you like. There's a password for that user, the regular user, not the admin user. So now let's run this command. Drop user because that's not there. So now we are going to create this user. Okay, the user is created. Now run the SQL. We are granting the permissions to that user. And then we are going to exit from there. Okay, then we are going to log in as that user, MySQL user 1. All right, the password is the same password. And then we already created the database, right? So we are going to use the database. Let's see whether we can, right? Show tables. Okay, so no tables are there. Okay, so now we are just exiting and back to the OPC user. Okay, so now we are going to go to the analytics instance. This is the instance name. We already created this, right? So we are going to create something called parallel private access channel. So let's go here. Analytics Cloud. And this is the BDS ASC. And there is something called private access channel to access the MySQL database. So, and here you give the name. You can give any name that you like. So that's what you enter here. And then this is the VCN, the same VCN we created, right? And this is the public subnet. And see, this is the DNS name, right, for that VCN. And subnet, and this is the so BDS VCN for that particular VCN. All right. Actually, I could have just checked this one. So we don't need to do that. All right. So if you do that, so it is going to pick from the VCN name itself. So that's essentially the same thing. All right. And that's it. So say configure. Invalid DNS. No. Save this. Okay. So it's creating the private channel. I think that was a small error there. Okay, I think I should, when we enter this, we checked in that checkbox. in spite of that, it was giving some error. So that's okay. So it is creating the private access channel. This is going to take a few minutes. So I'm going to pause the video here. All right. So I waited for a few minutes. It finally created the private access channel, right? So from OAC. So this is how you can talk to any MySQL database in that particular network. So that's the meaning of that. And now let's go back to the OAC instance. And you see, if you want to go to the home page here, you can do that. The OAC instance. Because we said we can access it from anywhere. I can access the public network, but we can have security policies saying that it can be accessed only from so-and-so CIDR block or particular IP address and so on. Now, see, so the next step is create a connection to the MySQL database. So create a connection. So let's create a connection to the MySQL database here. MySQL. So that one, and then the connection name. So here so this could be connection name that you specify. You can give any name you want. Description is the same. And you see, this is the host name for the MySQL instance. And this is copied from the previous app. So this was previously generated. You remember the fully qualified DNS name. So copy that, put it here. And the port number is 3306. And the database name is LiveLab DB. That's what we entered. MySQL. So instead of this thing, let me copy this. Enter the username. And the password is this. This password right here. And save. All right. So now, so that's completed. Now we are going to log in back to the utility node and copy data for basically for simulating the IoT, right? So that's what we're going to do. Let's go back to, this is utility node. So we are in OPC. So we need to, right? So that file is downloaded. Then we already unzip that. And we go to, now we go to Ambari and get the actual, Kafka Bootstrap server. This one. So we go to Ambari here, dashboard, configs, dashboard, services. We go to HDFS, and configs, and configs, advanced tab. So here are some advanced, and you see this one. This is the utility node, and that's what. Okay, so that's the one. See this one, and this port has to be 8020. All right. Then, oh sorry, this one. This is the This is the configs Kafka broker host, right? This is a Kafka. No, this one is different. This is the advanced configs advanced tab. Here we are getting the name node host. That's what we got, right? Managed, master node got it here, okay? Then we are going to Kafka configs. So go to Kafka here, configs, and Kafka broker host. See this one? So that is this. So basically copied and pasted here, same thing. And basically this is generated, but you can see the same thing here. Now we are going to edit the environment file here. So, and this is a configuration file input. So this is all automatically generated, by the way. You can look at all this command input, you can see. The idea is to, for you to, otherwise you had to make all these changes yourself. So here what you're doing is just take all this, put in all the environment variables, okay? So that is done. This is required for the Flink, all right? And then we are, what we are doing is we are going to execute this script. This is the first time actually you have to do this because first time you don't have to do this, by the way, sorry. You should skip this for the first time. Basically, this initializes the MySQL database and all that. So we don't need to do that. Then we need to go to the skip this. It's going to create a bunch of tables in the MySQL database and so on. So that's what it does actually. Okay, so the car IoT tables, all that it's created. Then we are exiting from there. And if you want to see the data in there, so you can just execute that. The password, basically we're just checking whether the tables are created or not, right? So that's what. Use LiveLab. And then show tables. So these are the tables that just got created. And it also seeds those tables with a bunch of rows. So 100 rows here, and driver info also is populated. So that's what the previous script did, okay? So just wanted to show you that. Then the next one we are going to do is, now we are actually going to be simulating this one. That was only the initialization part that we did. Now what we will do is we will open, we are in the utility window, right? So we can use the same window. And we are going to log in as htps. And we are going to start the Flink. Okay, so copy this all the way here and go to this window, right? So it's going to start on the Flink application. See this one? Just copy this and paste it here. And this we can use it later. Okay, so that's done. 006, 6. And then what we will do is we are going to open another window. All right. So this is the management node window, right? I can close this just to avoid the confusion. So I got a window here. I'm going to open another window. That's where it's going to be the Flink client, actually. So it is my. So that one. Right. So I'm going to log into the utility node. Then I'm going to log in as Hadoop htps. And this is a Flink client. Now what we're going to do is we are going to set some settings for the lab. Then fortunately these have to be executed one after another. For some reason Flink doesn't allow to copy all these commands at a time. Okay, sure this is executed. All right, so streaming is done, 3 seconds is done. Now we are going to create these mappings, right? So we are going to create these tables in Flink. So create table Kafka source, and it's going to map to the. It's going to map to the. It's going to create a topic. It's mapping to the Kafka queue, right? So you're basically creating a table on top of Kafka. That's what this is. That is great. And then is the next one. Let's return. These are the other tables. So there is then setting the dates. And after that, we are going to run this. Here it is mapping to this MySQL database. See that? So it's basically creating a table on top of this IoT tables, okay? Just a kind of view on top of that. It's that. Insert into. So now we want to track these vehicles 10, 11, 12. So that's what we're going to do. It's that. All right. Next, what we're going to do is next we are going to go to the OAC. All right. So now we are going to go to OAC. Okay, OAC here. We are going to create a data set. And we have this MySQL connection. And you see schemas, and these are live DB. So all these tables are there. So you double click on the IoT details table. So here, this is the one. Double click on that. So it's going to bring the table. And this one. So here, it's a longitude and all that. So this one, vehicle ID, basically it's saying So all these columns, vehicle ID, longitude, and latitude, change it to attributes. So for example, here, so if you see this, it just is a measure because it's a number. So what we need to do is you need to convert into attribute. Same thing you do for longitude. You do the same thing for this one attribute. So you got vehicle ID as attribute, latitude and longitude, right? That's what you do. And you can change the names actually. So if you want to change the rename, so we can say vehicle ID. This also can be changed actually. Latitude and this also can be changed as longitude. All right. So then, see in this documentation, now we can save this. There is no data right now, so we are going to come back here later. So save as. We're going to save this. Actually, okay, so here you can see edit definitions. So here, edit definitions is okay, there is a not that. What is done? Or here, that's it. So edit definitions, here you say not caching, live. You are going to, so say okay. Then you say save as. Save as, here it says. Save as a truck position point map, okay? Actually, driving info, actually, this should be driving info. Just type it here, but anyway. So driving info, okay. So that is done. So now we go back here. Now, so that's a data set. The next thing is we need to create a workbook. And we're going to use this data set, say at the workbook. And now what we're going to do is we are going to put the visualizations. There is something called a map. So if you want to visualize as map, so that's the one, map. Yeah. So double click on that. So that's what we have. Go back to this data. So now what we'll do is we have to simulate that IoT, right? We need to populate the Kafka queue. So what you do is go back to, again, maybe another window. You need another window actually. So you've got two windows. So we will go to another window. Let me open another window. So here, and then we are going to go to htps, login as htps, go to this particular directory where we downloaded the data. Right. So we are in that particular directory, and now we are actually going to be populating the Kafka queue. So send this data. You can ignore that message. So it is sending the data. Now you can see it's pushing the data into the Kafka queue. Now, while that's going on, actually, we can, let's see, we can go back to this one. So what you do is longitude, car ID, longitude and latitude, you put it into the map. Okay. So here, right, into the category field. So these two put it into the category. They will show up it on the map. So that's what you see here. And then vehicle ID, put it in the color. So you can see it's growing actually. If you just do a refresh here, so this every 5 seconds it's capturing the moment, right? So this is keeps growing actually. So this is at vehicle number 11. This is 10, and this is 12. You can see, and this was at 37. Latitude is 37.68, right? So now if you do refresh another time, so it just keeps growing actually. So every car is moving, you can see. All right. So that one is actually populating. Once this finishes, you will see a trail of all the thing. Okay. So that is the first lab. So you can see as the cars are moving, you can track their location. All right. So that is the first demo, right? The IoT demo. Then the next one would be what we would do is we are going to identify the hazardous road conditions, and we are going to alert, right? And if you want to look at the Flink job and all that, you can use this URL. And by the way, this is also generated based on the previous input, all right? Just for that, if you want to know, you can just copy this. By the way, that huge job got completed. It took 7 minutes. So if you want to look at the Flink jobs, so I can see they are running and all that, okay? Running jobs. Some of these jobs are running, right? Let's go back to, so this is still pumping the data. So let's go to workbook, refresh. A much longer trail you can see, right? This is the latest position. And this will be completed in another, oh, it's completed. So this is a complete track, right? Now we can save this as, um, truck position point. So that's completed. So now the next one is we are going to identify the hazardous. So again, go back to the Flink client. In the Flink client, you create this mapping, right? Okay, client here. what is the problem here? Let's see. Oh, okay. Only one statement is allowed. So what was the previous statement that we did not complete? Was it this one? Not sure, but I think we already created that. So let's. Well, that was the insert thing we completed. But after that, we did not create this table. Okay. So we need to. Oh, that table is already created, I think. Okay. So now we need to, oh, sorry, this we ran. Then we need to run this. Okay, now let's run this. Oh, you know what? I ran this drop table if exists and so on. So they copied this entire thing. That was a mistake. You can run only one at a time. So it's the one. So because this is the first time, I don't need to repeat that. Oops. I don't need to that. That is completed. This car info is created. The next one is driver info. So we copy up to here. That is done. Then we are going to create a dangerous road. Then you can review these SQL statements later, but basically they're all from the lab. Just that we are using the actual values. The lab notes, they use parameters, but parameters are not supported. That's why we are using the values. And these are all generated actually. So based on your previous input, all these commands are generated for you. So that way it saves your time significantly. So this computes the distance between the current location of the car and the hazardous location. So this is, I believe, it is 6.37 million miles. I believe this is the distance. This is the radius of the Earth, I believe. So this is the formula for computing distance between 2 points on the Earth's surface. So it's that. And then insert into this road. Okay, so it is that. They're inserting into that dangerous roads alert table, and we are going to view this using the OAC. All right. Now, just to see whether we have this data in this MySQL database, we can just we can log into MySQL database host. Okay, so we are already in this. So let's see. Okay, so let's log into MySQL. And the password is this. Use LiveLab and just see whether this table that was created here, right? We are created the dangerous road alert table, and then we inserted. So let's see whether we have any data there. See, there are 10 rows are selected. So now we can go to OAC, we can visualize that. So it's very simple. Go back to create a data set and take the same connection, go here, LiveLab, and then use create data set is equal dangerous road alert. So dangerous road alert. So that's the table, right? So this one. So double click on that. It's going to bring that table. And here we need to change the right. Right. So this shows you the data in the table. Now we can change. We can go to this tab and we can change the according to this LiveLab. It says except GPS, except time GPS, all the other things are attributes. So vehicle ID is an attribute. It's an attribute. This the second one is the time GPS. So that's not an attribute, right? That's what it says. Car speed is an attribute. You're not going to aggregate, right? So attribute and road is an attribute. I think there's a way to select multiple columns and make them as attributes, but I'm just I'm not a power user of this tool. So attribute. This is anyway attributes. So, capacity, an attribute. Driver ID is an attribute. So everything else, right? So if you look at this, only the time GPS, other than that, everything is an attribute. So if you see that A, that means it's an attribute. All the way. Okay. So now what we are doing is done that. Then now we are going to set the edit the definition. Edit the definition. See this one. We are going to make it live because we are going to. And then we are going to. Then we are going to. Actually, the LiveLab says you need to rename these attributes to a more meaningful names, but I'm skipping that. So let's save this as dangerous road alert. This data set. All right. Okay. Now we are going to basically visualize that a simple report, right? So we are going to go back here and create a workbook using this data set. So drag and drop. So it says GPS on that. Into a tabular report. Table. So we just want to visualize this as a table, right? So just double click on that. And then go back to the data and basically you pick all the columns. So here, GPS, drag and drop GPS time on that into the detailed rows column. So GPS here, and then car speed, driver name, and so on. So car speed, driver name, driver name, driver name, longitude, latitude. So longitude, latitude, and latitude road class. So road class is here, and then road class, road type, junction control, road type, junction control, and junction detail, So drag all this and put it into the rows. All right. So then you can see all that. All right. I mean, this column can be moved, I guess, to the beginning. So that's the data. That's all. I mean, and then you can. So this is the. So at that time, you know, these are the people, these are the drivers. You want to alert. That's the report actually. So now you can say save as. This is the warning, dangerous. So just this, save that, okay? So that is done. And the last lab is this. It's even simpler. So what you do is you go to the utility node, right? So we already have a window, utility node. Exit from here, it's the root. And then actually, so it says utility node, start the Spark client. So here you go. Paste. On that. See. Paste. All right. Then exit. Then what we are going to do is we are going to log in as HTFS. And basically, we're changing the permissions of that. Actually, there are some log files there. And when you're running the Spark job, it cannot write. So this is a change from the lab guide. All right. So just this is additional change. So now we are going to log in as HTFS and run the actually PC. I cannot do. Can I do sudo su as HTFS? Oh yeah, I can do that. So then so now it's going to run the actual Spark SQL. All right. Now we are executing Spark SQL, and so here you can see we are creating a view on top of this tables, right? I mean, on this MySQL. So Spark is going to be operating on top of this multiple databases, but in this case, it's just the SQL, MySQL, right? Oh, hi. So let's complete the last demo. Yesterday, I tried to do this, but the Spark job was not getting resources from Yarn. And I realized later that it was running a couple of jobs from the previous demos. So I had to just cancel those jobs. And once I did that, it went through fine. So I just want to repeat it. So let's do this, right? So the data is already sitting in MySQL database. So Spark, we are going to use Spark for aggregating the data. So we're going to read it, process it, and store it back in MySQL, the aggregated data, and we are going to visualize it through Analytics Cloud. It's very straightforward. So let's quickly do that. So here are the steps. So let's open a window, bash window. So that's what this one is. Got that. And then we already did this part, right? Yesterday we did this. So let's just run the Spark SQL. So that's what here is. And then after that, we are going to create the mappings to the tables in the MySQL. So it was straightforward. I'm just going to copy and paste this here. Here we go. This is Spark SQL. So just paste that. Done. Then the next one is this. And the third one is this. They're all, by the way, all these mappings are to the tables in MySQL. They, Spark SQL is actually pretty versatile. It can access data from different sources. It could be Oracle, non-Oracle sources. But in this demo, we are doing a very simple one, right? So driving analysis result. So let me paste that. That is done. Next one is this. Okay, and the file. So here we are basically doing the aggregation. See this, we are inserting into the driving analysis result table. That's going back into the MySQL database. All right. So that's it. And finally, we are also inserting, we are just doing an aggregation of this table, right? Average fuel consumption table. We are just putting into correlation of, we can do this also. So this is done, right? It took 24 seconds. Yesterday, as I said, it was not getting the yarn resources. So here, let's do this final one, just one last thing. And that's it. So now let's go back to the Analytics Cloud and look at the table, right? The driving analysis results. So here we go. So I already have the Analytics Cloud. So here we create a data set, just like what we did for the other two demos. The connection. Is the database, and table name is driving analysis result. Driving analysis result here. So double click on that, and then it says set vehicle ID and driver ID to attributes. So click on this. Vehicle ID, driver ID. Okay. So vehicle ID is an attribute, and driver ID is here. Yeah, this is also an attribute. Then you have capacity. Capacity is here. Capacity is also an attribute. So we got that. Then average speed. Average speed is here. Average speed is also an attribute. So it's this. And then we are going to Here the lab says you can rename the columns from driver name to much more readable. In the interest of time, I'm just going to skip that, and we will save this data set. Right, we'll just save this and right, we'll save this. And just check this. Okay, so we will just save the CMS. Driving analysis. So it is the same name. All right. Then we are going to go back. Now save. And we are going to visualize, right? So we are going to create a workbook and the driving analysis. This is the one we just created, right? So add to the workbook. And here, so we are going to use the table visualization. So table. So double click on this. And then go back to this data. And then what we are going to do is we are going to drag and drop driver name, car type, driver name, car type, car capacity, here. Then driving anomaly. That's driving anomaly amount. Amount is okay. See this one? We did not rename this one. CNT count. So the count is the this one. So that one. Anomaly. Average speed is here. Average speed. Total fuel consumption. So just drag all these fields into the rows. That's here. Right now we have the driving gender into the color field. So driving gender is here. So just put it into the color field. So that's what it shows here. That's pretty much it actually. So we say save as driving analysis, right? This workbook, you just save it as save. That's pretty much the demo. So it's very straightforward, as you can see. Anyway, so I just wanted to make sure that the demo ran successfully. So let me stop the video. Thank you very much for your time today.